Our CCIE class study today.
Yeah.
So today I will just talking about couple of the fundamentals. Okay. Only I will talk about little bit of the fundamentals. Then
You are
soon.
recording the screen. You are recording the session.
Sorry.
You are recording. You start
Yes.
recording. Yeah,
It should be.
please.
It is recorded. Okay.
Yeah. Thank
You
you.
will get the recording. Don't worry. So we will start from the basics, and soon we will go to the advanced level.
Yeah.
Okay. So let's start with a very basic thing, but very important thing. Okay. So I
Yeah.
am just starting from how the communication happens among two devices. Okay. So let
Okay.
us say there is a user. This user wanted to go to google.com. Okay.
Yeah.
So if this user need to open google.com, how the communication happens? There should be a server, Google server somewhere residing, maybe in his country or his or her out of his or her country. Okay. So
Okay.
how this communication happens? Very simple. When user will put out google.com, then a DNS request will go. DNS reply will come. There will be some IP which will get formed. Just hypothetically, I am taking that IP 1.1.1.1. Right?
Yeah.
This packet will go to your modem. Some modem should be there of the ISP, and here you can have a LAN connection or you can have a WLAN connection, howsoever. Then next, this modem should going to the ISP router or router, whatever you wanted to say,
Yeah.
right? Then again, there can be more routers into the picture, right?
Yeah.
And here can be, there is something NAT which should be used, which is making our private IP to the public IP so that our communication can go from a private range to the public IP range. Then similarly, there can be n number of hops. I don't know how many number of hops are there. My traffic will go to the Google data center. Let us say this is Google data center. Now, in the Google data center, it might happen that there is some load balancer. Okay. And from this load balancer, the traffic must be going to one of the server. There can be n number of servers, 5, 10, 20, 30, 40. Before this load balancer, there might be a firewall. Okay. In the Google data center, there should be a firewall, which should be making this all requests secure. There can be a web solution, web application firewall, which might be securing your layer 7 traffic. And before there, maybe there is a Google, entry point, or we can say a router. So whole of the communication will come from here, going through all of these hops, through the firewall, through the web, then we'll go to one of the server, right?
Yeah.
And this is something named as request. So this is my request is going. Same way, my response will also come. Okay. So that is how my traffic will go from one system, or I can say requester to the, or it is a sender, or it is a receiver. Okay. We can say that this side, it is sender who is sending the request, sender who is receiving the request is receiver. So from sender to receiver, that is whole kind of transactions happen. Any doubt?
Not okay. Fine.
Now I need to bring up couple of more points here. See, to make these all communication simpler, okay, in 1980s or 1970s, I will say, your one model was created named as OSI. Remember?
Yeah.
Very old. Okay. OSI model. OSI stand for Open System Interconnection, which means like how the communication happened between two systems, as I was showing you earlier. In 1984 or maybe before than that, this whole model came. Okay.
Yeah.
This model has 7 layers. Okay. It is consisting of 7 layers. And using these layers, please be noted, every layer has their own protocol. Every layer has their own protocol. Okay.
Yeah.
How come these 7 layer come? Depending upon the different uh, scope of work. Okay. The work how we are doing is divided into 7. I am just giving an example. When you are sending an email to somebody, to your client, or maybe to anybody, you are using a protocol named as SMTP. This is a protocol. Sooner or later, you will able to understand about these protocols, right?
Yeah.
So you are using SMTP. Let us say you are uploading something on Google Drive or somewhere. Okay. You might be using FTP. Okay. I'm just telling an hypothetical situation. So protocol name is FTP there. Okay. File transfer protocol. You're transferring the file. But when you are accessing something like you are opening Google, YouTube, Facebook, maybe any banking site, you are dealing with some protocol named as HTTP and HTTPS. Yes or no?
Yeah.
All of these protocols, whatever I am describing here on this screen currently, are the layer 7 protocol, which is application layer. This is the top layer, layer 7.
Okay.
Any doubt?
No, it's okay. Fine.
Right. So application layer, specifically, if I will talk about, it establishes a communication between the application and between the user. And there can be different protocol, as I told you, HTTP, FTP, SMTP, such kind of protocols are there so that your user can interact with the applications. No doubt, yeah.
Yeah, it's okay.
Then I told you that it is divided into 7 layers. Layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, and layer 1. Okay.
Yeah.
Here I talked about it is application layer, right?
Yeah.
Then you will be having presentation layer. Presentation. Then you have session layer, transport, network, data link, and physical. These are your 7 layers. I talked about application layer before some time. Now let's say once this thing is started, okay, you are trying to maybe access Google, trying to send some, email or something. So next your traffic will go to which layer? After application, it will go to the presentation. Presentation layer role is to encrypt the data. What the encryption mean? See, over the internet, if you are sending some data, let us say you are doing some banking transaction and you are sending your account number like this. Okay, 23, whatever your account number is, maybe 741071023 is your account number. So if there is some hacker, he or she can manipulate this data. So besides sending the clear data, okay, we don't send the clear text. We make it change. So maybe we convert it into some of the ciphers. 1, 2. So although this data, if we will reveal the actual data, that is your original data is somewhat which I am describing over here in the blue color. But this is encrypted data so that if some hacker or some man in middle, okay, man in middle wanted to see this, he or she won't be able to find it out. So your whole thing is encrypted. So this encryption and decryption need to be done on which layer? On the presentation layer. And as it shows that it talk about the present, like how to present the data. So it will also compress the file. Compression, I hope you are aware that if you have a file in the folder, you have couple of the files. Okay. It is taking 1 GB. We usually what to do? We compress it through the
Yeah.
WinZip or something. And we convert maybe into the 700 MB. Okay. So 300 MB, we save that.
Yeah.
Okay. So that is compression. So presentation will do the compression and it do the encryption and decryption. I hope there should not be any doubt so far.
Yeah.
And it use its own protocol named as NFS. So if you have heard about network file system, yeah,
Yeah.
that is the part of your layer 6, which is presentation layer. Okay.
Yeah.
Then once the data will come to the layer 7, from layer 7 to layer 6. Now from layer 6 to layer 5. So from layer 5, it will see that, okay, presentation layer, you give it to me. Now I will check. There will be a session get established between the sender and between the receiver. It will try to create a session. Okay. This may use something, a protocol named as RPC, remote procedural call. Or if you talk about Windows, we are NetBIOS. There is a data. So as a network admin, these 3 layers, we don't bother much. Okay. We don't deal in these layers generally. As a network admin, we must be aware about lower layers. Getting my point?
Yeah.
So let's talk about from the transport layer so that you can able to understand. Now, as I told you, there is a user. Okay. There is a user and there is a receiver. User send some data. This data come from application layer, okay, presentation layer to session layer. Then where it come? This data come to your transport layer. Transport layer will put some kind of header on the top of it. Header means some information. Okay. So it will put layer 4 header on the. When it will come to layer 3 header will get on the top of it. When it will come to layer 2 header will be. So actual data is where? Actual data is this. But some headers are got inserted by every layer. This part is clear to you. Getting this point?
Yeah. Yeah. Yeah.
Right? So when it come to layer 4 and layer 4 header is there, it is named as segment. And in the layer 4, there are 2 protocols which come into the picture. Very important protocol. One is TCP and one is UDP. Right?
Yeah.
When it come to layer 3, it is named as packet. Very important protocol as of now is IP. Earlier there was Apple Talk and lot of other protocols also.
Okay.
No doubt.
Yeah, it's okay. Fine.
Once it come to the layer 2, it is named as frame. And the protocol which come into the picture over here, because now generally we are using Ethernet. So it is MAC. If it would be your serial link, it can be SDLC, it can be PPP. Okay. In the
Okay.
serial, layer 2 can be HDLC or PPP. So you need to understand one thing, that whenever your data is coming from the upper layer, then lower layer will put some kind of header on this. This header has some information. Okay.
Okay. Yeah.
I hope no doubt so far.
Yeah, it's okay.
So again, there is a requester and there is a receiver. So this is a sender, this is a receiver. Sender some data. Okay. That data from layer 4, when it will come, this data will have some more header. As I told you, data has layer 4 header, then layer 3 header, then layer 2 header. And when it will come to layer 1 only talk in the signals, or you can say 10100001, whatever, because you need to understand, computer or machine only understand binaries. Binary means 1 or 0. In decimal, we have 0 to 9. But in binary, we have 0 and 1. So whole data, in case of binary, in case of computers, will go to 1 and 0. So whatever email you are sending, whatever file you are sending, all the file is containing 101010 binary only, nothing else. Once this signal will come to your receiver end, it will have layer 2 header, it will have layer 3 header, it will have layer 4 header, and the actual data. Okay, so
Yeah.
this is your data. The same data will come over here. Now on the layer 2 header will remove, it will send to layer 3 with layer 3 and layer 4 header. Then on the layer 3 header will remove, layer 4 header will there. Layer 4 will also remove, and actual data will send to the receiver. That is how your end-to-end communication happens.
Okay.
But let me tell you, every layer, as I told you, have their own header. Okay. Or we can see, we can talk about this term PDU, protocol data unit. Okay. This is protocol data unit. So you need to understand, let us say, this is my sender, this is my receiver. Sender generate a data. Okay. This is the data. This data, let us say, is of 400 bytes. Okay. And we used to keep on putting headers on it. Let us say layer 4 header, layer 3 header, layer 2 header, bit like that. And eventually it will go from wire, as I told you, in binary, right? 1010 kind
Yeah.
of thing. So there can be n number of hops, as I told you earlier, that there can be a lot of routers, right?
Yeah.
And every router has a limit. Like if you are going on a road, okay, if there is a shorter road, there can be one car can go. But if you are going on highway, there can be one car like over here, or two car, or if it is a 6 lane, so there can be like three times here, three times here, right? Bit like
Yeah.
that. There, depending upon the road size, your cars or your traffic can go, right? Yes or no?
Yeah. Yes, yes.
Similarly, here also, let us say this is a shorter road. Only one car can go. I'm just taking an hypothetical example. So this is something named as MTU, which is maximum size of IP data can transfer. So how much data can transfer from one place to another place? It, it will be decided by whom? By MTU. Is
Okay.
this part clear?
Yeah, yeah.
So we need to be very sure, if my data is, let us say, if my data is such a bigger, the road is smaller, what I need to do? I cannot send the data. I need to divide the data. I need to chunk the data. Okay.
Okay.
And I will send this data in the smaller form. So I divided my data, let us say, in 4 or 5 packets further. So now the same data will go there in the 4 or 5 packets. Is this part clear?
Yeah.
This is named as something fragmentation. So if my MTU size is not up to the mark, then there can be fragmentation which is needed. And once we are doing fragmentation here, another side, I need to make this data again. So from that fragmentation, I will create the same sort of data which was here. I will create the same data over here using these small blocks, bit like Legos, that we are creating the Legos and making something. Okay.
Yeah.
So if one of the packet fails, let us think if this packet fails, then this whole data is of no use. So this fragmentation is not good. Why? Because if it fails, we need to retransmit. Retransmit means we need to send it again.
Yeah.
Also, if I have a shorter road, the traffic, this car need to get wait, okay, till these cars are coming. So it will increase the overall efficiency. So negative impact is there for efficiency. Sorry, it will increase the latency.
Yeah.
Okay. So latency, which means it will get late, will get
Delay.
increased.
Yeah.
These are very important topics. Okay. And
Yeah.
generally asked in the interview also. Please do understand, this is asked in the interviews. These are
Okay.
the interview questions. So as I told you earlier, I was OSI model, right? Which was having application layer, then presentation layer, then session layer, then transport layer, then network layer, data link layer, and physical layer, right? But
Yeah.
nowadays I am having TCPI. Upper three layers, these upper three layers are named as application layer. Transport is the transport. Then network is the internet, named as internet. And the below two are named as network
Net.
access. Please do let me know if you have any doubt.
Yeah. Yeah. Sure.
So do you have so far any doubt?
No, no, it's okay.
Fine. Let me now talk about something about the routing principles. I am starting from the history, like which may be not used now, but I am starting from the history. Okay.
Yeah.
So let me ask a question. Let us say I was talking about whole of the story. If a packet, now I am just coming to the routing, which is layer 3. Let us say if a packet come on my router, okay, what will router does? Try a guess.
Not sure.
So this packet, let us say, need to go to 1.1.1.1. Okay. So
Yeah.
this is destination, which may be a Google, as we are trying to do some hypothetical situation today. Okay. So what this router will does? Any guess? It's not an interview. So it should be an interactive class. You need to tell me like what it will do. What kind of lookup process happen inside into the router? what the router will do.
It will guide you to the destination, I think.
Yes, that's true.
Yeah.
It will. But how?
I think through the protocol or something.
Right. Let me
Yeah.
tell you now. Okay. One thing you need to understand, any router or any device. Okay. So I hope you are aware about the routers and these things. So if I will show you router, or let me show you the uh, Cisco routers. Okay. These
Yeah,
are the
yeah.
devices. These are the devices. Very simple
Yes,
devices
yes.
you can see. Right. So
Yeah,
these are the routers. Okay.
yeah,
Now, what happened is I am just creating like this, but don't get confused that it is a round in the shape. It will be a bit like in the rectangular shape. Okay.
yeah,
So router, you can log in over here through the SSH or through the telnet.
yeah,
Telnet, telnet is a very old protocol and not safe.
yeah,
Okay. So we don't use telnet nowadays. We use SSH to go into the device. One
yeah,
thing. So when we are SSHing our router, it means we are accessing the
man,
management plane, right?
yeah,
So when you are taking the management of some device, either through the telnet, either through the SSH, nowadays through the APIs, okay? Anyway, so all of these protocols are doing what? They are taking the management, which means we are entering into this device, we are logging into this device, and we can do a lot of work. One thing. Then on these routers, if you are running some kind of protocol, some protocols are running there. Let us say OSPF protocol. I am talking about routing protocol.
yeah,
They will exchange their packets and they will form some kind of table inside into that. These kind of packets which protocols are running are named as control packets. Or we can say it's a control plane, which my router is handling is the control plane. Yes or no?
yeah,
But when any data is coming, my user is trying to access something and it is going from the router. When user traffic is coming, it means my router is handling data plane. Getting my point? So router is handling the manage plane also. Router is handling the data plane also. Data plane means user traffic. And router is handling the OSPF kind of packets, HSRP kind of packet, ARP kind of packets. If there is spanning tree also running maybe behind the scenes. Okay, although it should not be on the routers, but just I'm talking about. So all those packets are the control plane. Any question?
yeah,
So if you see, our router is doing three functions here. Okay, one is management plane, one is data plane, and one is control plane. Control plane is for the uh, your routing protocols or some kind of protocols traffic when it is handling, it is control plane. When user traffic it is handling, it is data plane. And when some kind of telnet or SSH you are doing, that is management plane, right? Later on, when I will teach you SD-WAN, okay, then you will see all of these planes will be segregated, which is decoupled. Means one device is not doing three planes. They will do single plane. Okay. But in SD-WAN, I will teach you that. Currently, let me just go forward. So what I was talking that once your traffic is coming on your router. Okay. My question I am repeating again. So there is some traffic is coming on my router. Let us say it is destined for 1.1.1 and router maybe need to send it to some other router or some other router or eventually to the Google server as I told you earlier. Okay. So what happened? Here, when traffic will come, it means which plane I am talking? I am talking about data plane. It's not a control plane.
Yeah.
Getting my point?
Yeah.
So when it will come on the router interface. So as I showed you, there are some router and
Yeah.
you have router interface, and on the router interface you have the cables, and traffic is coming on this interface, right? So
Yeah.
when traffic is coming on the router interface, right? So it will check that okay, something is coming to me. There is something named as interrupt manager, which will get invoked, means it will become active. Okay, interrupt
Yeah.
manager, that okay, there is something happened to me, something comes to me. And as I told you, when traffic will come on from layer 2, see, from layer 2 there would be layer 2 header, then layer 3 header, layer 4 header, and all the headers are there, and then eventually there is a data bit like that, right?
Yeah.
So from the layer 2, there is a field. If you will read about the layer 2 packet, okay, sorry, layer
Yeah.
2 header, I will say, there
Yeah.
is a field which is describing what kind of layer 3 packet it is. Can you tell me the name? What is that field?
Um,
Let me show you, don't worry. If I will go for layer 2 header, so you can see layer 2 header named as Ethernet frame,
that's
okay?
okay.
And this is the complete frame. This all information is inserted into layer 2.
Okay.
Getting my point?
Yeah.
This is the whole information which is there into the layer 2. And there is one field named as ether type. Can you see this?
Yeah.
This ether type field will talk about what kind of layer 3 packet I have. If I will just go down for the ether type, let me show you. So Uh, is it talking about, or should I go to some other? Let me go for ether type. Ether type. So you can see this is your
Yeah.
ether type, only 2 bits. Okay. And
Okay.
here the ether type value. Can you see these values?
Yeah.
If in your ether type, this value is there, it means it's an IPv4 packet.
Okay.
If it is the value of 0806, it means it's a R packet. Bit like you can see there are a lot of packet details, like if you have 0x886DD, it means it's a IPv6 packet. Why this is important? This is important because once this information is there, interrupt manager is aware on which queue in your router there are a lot of queues. It can be a layer 3 queue, layer 3 maybe IPv4 queue, layer 3 maybe IPv6 queue. Okay, bit like there are lot of queues. So it should be aware on which queue I need to send this packet.
Okay.
Is this part clear?
Yeah. Yeah. Yeah.
So ether type, as I was talking about in this frame, there is ether type field which talk about how or what kind of layer 3 I have. Similarly, in layer 3 packet also, there is a field which is talking about the layer 4. Not completely, but it will tell either it is a TCP, either it is a UDP, bit like that, so that your packet can be sent into the same queue. Are you getting my point?
Yeah. Yeah.
So one thing I talked about, that whenever any packet is coming, okay, your interrupt manager will get invoked. It will have the information that what kind of packet I have. and router will send it into the same queue. So I am talking about the story inside into the router. Okay. And not
Okay.
about the control plane. Control plane story is different. I am talking about data plane currently. Only data plane, simply data plane. Okay.
Yeah.
So once this packet is there, my CPU will get instructed that boss, there is some packet and I need your intervention. What I do, what I need to do. So CPU is bit like you can say mind of this router. This router mind is inside into the CPU. Bit like if you purchase and if you have purchased any mobile or something, what you check, what kind of RAM it has, what kind
Yeah.
of memory storage bit like, right? So
Yeah.
every
Yeah.
hardware has some memory, some, brain. So this is CPU, which is the brain of router. So now router is saying, okay, CPU, I need you. Tell me what should I do with this packet. Now let me tell you. When you have one brain, okay, and your data traffic is coming, and your control plane traffic is also coming. Your two traffic I talked about, right?
Yeah.
So you tell me which traffic CPU will handle.
I think
Sorry.
both of them.
So control packet is having the high priority
Okay.
always. Okay. It is bit like if you have two works, you cannot do the two works simultaneously. You
Yeah.
need to you need to complete one work and then you will go for the another work. And how you choose first work depending upon the priority. So always remember control packet have the priority of 6, which is high priority. So if my CPU is not free, this data, okay, this data traffic will be need to get wait till my CPU is free. Okay. Once my CPU get free, are you getting my point?
Yeah. Yeah. Yeah.
My CPU is free. It will start look up that, okay, you need to go out from this interface and it will send that traffic. But obvious, we'll do some kind of routing lookup, okay, and it will
Yeah.
send the traffic out. So let us say this data come to the ETH 0 by 0 port and it is sent out from ETH 0 by 1. So in between, what happened? I hope you are getting this point. Yes or no?
Yeah. Yeah.
And for taking the decision, CPU will take the decision depending upon a table. That table is RIP, routing information based. So it has a table that, okay, this if the traffic is coming from this interface, from which interface it has to go. Because router may have different interface. It can have multiple interface. So from which interface this traffic should go. So if traffic is coming from here, traffic is need to go from here. CPU, depending upon the rib, depending upon some table, will check, okay, this should exit from such an interface. Are you getting my point? Yes or no?
Yeah. 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 Yeah.
Let me just talk more about it. So it is bit like postman come to you to deliver some kind of package. But in the building, there are maybe 100 floors. Postman cannot go to the 100 floor and can say that, okay, is this with you? Is this for you? Is this for you?
Yeah.
Postman should
Sure.
have some address mentioned there, right? Depending upon that
Yeah.
address,
Sure.
postman will send it to the specific floor.
Yes.
Similarly, our router need to exit from one of the interface and for that it should have some address and that is your routing information based. So it has some kind of table.
Yeah.
Any question?
No, no, it's okay. Fine.
Okay. So whatever I talked about this thing, okay. So I hope you able to understand. Now let me
Yeah.
proceed further. Again, the same scenario, but I am asking you the question, more question over here so that you can able to understand. And let me tell you, these are very, very important topics. Okay. You cannot say that it is a very basic, but very important topic which I am talking about. Let us say again the same scenario, traffic is coming for 1.1.1.1. And I talked about that it will check its RIB, router information based or some kind of address. And let us say that information is not there. Earlier I talked about that, okay, 1.1.1 should go from eth 0 by 1. This information was there and it sends from eth 0 by 1. But let us say now there is no information. This information is not there in the RIB. Then what does this CPU will does? Is the question clear to you?
Yeah.
So what it should do?
It will again to send the data or
No, it cannot send the data because it does not have the information where to send.
okay.
It will simply drop that packet.
Okay.
You can say drop, you can say discard. So it will simply drop or discard the packet. But that is not important. Important is something else. When it will drop or discard the packet, it will also send this information to the sender that I don't have this information using ICMP unreachable. I hope you have seen such messages.
Yes, yes, yes.
Whereas this is a very big problem for your environment. Let me tell you how. Let us say you have a router and there is a hacker. Hacker means who is not a good guy, who wanted to steal some data from your company or who wanted to make your device down. And this hacker knowingly sending the data to your router, which your router does not have in your RIB. Every time what you are doing, you are dropping the packet and you are sending the reply. For every packet, you are sending the different reply. And it is sending maybe thousand of the packets. Okay. And you are sending thousand of the reply. Your CPU is getting exhausted, which means it is becoming high, 100% CPU. Now your CPU is so busy that if your control packet is coming, your CPU does not have anything. It is dropping even control packet. It is bit like sometimes you have so much work that you leave every work and you go to sleep, right?
Yeah.
Same way here, router cannot able to do anything, able to do anything. And that is where the problem occurs that your device is malfunctioning. It's not functioning properly. Okay,
Yeah.
it's not functioning properly, it's malfunctioning. Okay, and that
Yeah.
is where the problem occurs. And there is a best security practice to do the silent drop, which means if I don't have anything, I need not to send it to the user. I need not to tell to the user that there is IP unreachable. Just drop it, which is named as silent drop. Silently, you are dropping.
Okay.
For the same, on the interface, you need to go to the interface and you need to give the command no IP unreachable. You must have seen those commands in your environment,
Yes,
but
yes.
I hope you are able to understand what is the significance of these commands. So there is a lot of significance, lot of
Yeah.
importance to these commands. Is this part clear?
Yeah, yeah.
Any doubts so far?
That's okay.
Now, as I was telling you that there is a sender. That sender is sending a traffic. Okay. And that traffic is maybe everybody is trying to give to somebody, and nobody has the actual, route. They are sending to their default routes. And the traffic is moving among them. Okay. So it can be a scenario that there is an infinite loop. Can you tell me what is the mechanism in layer 3 to stop this infinite loop?
Routing?
That is TTL. Have you heard about it? Time to live. Very important.
Yeah.
Time to live means whenever a user sending a packet, whenever a packet is sent, this packet has a time to live, let us say 30. So on the first router, on the second router, third router, and on the 30th router, it will get dropped. So that this packet should not be looping infinitely over the internet forever. Otherwise, if we don't have such kind of, prevention measures, then there can be a lot of such packets which may exist infinitely into your network.
Yeah.
Be aware. For layer 3, there is TTL. For layer 2, there is no TTL value. And that is the reason your layer 2 loop is very hard to recognize because it become infinite. And always, when there is a layer 2, maximum time what I heard is somebody has to go and unplug the cable so that this loop will stop.
Drop. Yeah.
I hope you have seen such things into your environment earlier.
Yeah.
So you got the point, like how layer 3 loop is getting avoided and what about layer, right?
Yes. Yeah.
This TTL value is very important in the trace route. Have you heard about trace route?
Yeah.
So what we does, let me show and open my command prompt and let me trace for something. Trace route for maybe facebook.com. So you can see there are some hopes it is showing. What it is
Yeah.
showing? It This is my PC. I am need to go to the Facebook. I wanted to check how many devices are in between,
Yeah.
right? So it is telling all of the device details. So first device detail is there. It is showing you one. Then this is second device. Then this is third device. And eventually it is going where? It is going to my server.
Yeah.
So how many devices for the Facebook? There are 9 devices,
Yeah.
right?
Yes.
In between me and in between Facebook server, there are 9 devices. So, or we can say 8 devices because, like first device is myself, this is server. So you can say these are the in between devices, right?
Yes. Yeah.
How this trace route able to find out these detail? Any clue? Very simple.
Layer 3 protocol or
Sorry.
through the layer 3? It's layer 3.
Okay, let me tell you. Don't worry.
Yeah.
Again, important question with respect to the interview. What I am talking how trace route works. Okay.
Yeah.
So trace route is bit like a hack. It is bit like a hack. I can tell you how it works into 5 points. First, user will initiate the trace route command, right? As I did. traceroute will set TTL value is 1.
Okay.
Getting my point?
Yeah.
So now you try to understand. Here, if I will just send this with TTL value 1, my packet will get expired here. It will send the information that I cannot send it, and it is revealing its information. Then it will set the TTL value 2. This guy will send the information. Then 3. Then this guy will send the information until 30 hops. Generally, by default, it will send the 30th TTL value. Yes or no? That is the reason why when you run the TTL, you could see up to 30 hops. Point clear to you, Mr.
Yeah,
Mohammed?
yeah. Yes, yes, yes.
So this process will keep on repeating. And when everything is finished, traceroute print all the hop information with the round trip timer. Like it will tell how much time it is taking to go till this device. So this is very important functionality. Through this, you can able to check how much time my device is taking to go to that hop. Any question so
No,
far, please?
no, no, it's okay.
Okay, enjoying?
Yeah, yeah.
Fine. Let me now go for that again back to our topic. What happened when traffic is coming on my router? Okay. So earlier thing what I talked about that is not used nowadays. Just FYI. Okay, that was very old technology. Okay, not used nowadays, but initially that was used. Maybe you can say 20 years ago. Okay, and
Yeah.
that was named as process switching. So the CPU got invoked, what I was telling, that was process switching. Now I am proceeding for the, mm, you know, newer to that. Still, we are not using this. We are using something more newer named as SAF, but I am just talking about this now, fast switching. Allow me only 1 minute, okay?
That's okay.
Fine. So I was talking about fast switching, which again currently not in use. Multiple of the vendors are not using that as well. But we need to talk about same thing. Okay. Same question. Question is same. When some packet is coming with some destination 1.1.1.1, how my router will behave? And here answer is it will do the same thing what I talked to you earlier with some exception. That exception I need to tell you. Okay. It will give
Yeah.
some relief to your CPU. So first time when traffic will come, again interrupt manager will invoke. Okay. CPU will come into the picture. CPU will tell all the information. But once it is done, it will create one more table. Okay. That is named as cache, or you can say route cache. Okay.
Yeah.
Route cache will come into the picture. Now, when second time this traffic will come, earlier, no matter how much times packet is come, CPU will get invoked. But this time, CPU will not get invoked. It will check the route cache and traffic will send out. So let us say it's coming to it's 0 by 0. Depending upon this cache table, it will go to the it's 0 by 1. So your CPU is now little bit relieved.
Okay.
So by root cache, second time, second time CPU involvement is not required. Any doubt?
No, it's okay.
But the thing is, if there is a new packet is coming to maybe new destination, okay, again CPU will get involved. So first time you need to do the lookup, and again your CPU is coming into the picture. And let us say if your DOS attack is happening, DOS means when these IPs are generated by using some script. Somebody is sending the traffic like 1.1.1.1, 2.1.1.1, 3.1.1.1, or whatever. So every time your CPU will get invoked because it's first time. And that is the problem. And that is the reason why Cisco discovered Ceph. Ceph switching. Okay. We
Yeah.
used to talk about Ceph switching also. Ceph switching is really very important and really very simple. In this case, CPU will not involve. Okay. Let me tell you, our devices are also getting evolved. Means our devices are becoming intelligent. If you have gone through any of the Nexus device, have you? Or maybe ASR devices, big devices.
Yeah.
There, this is bit like a bigger router, like this. Okay, let me
Yes.
show you. Give me a minute, let me show you.
Yeah, yeah, I know that.
See,
Yeah.
these are your devices. Okay,
Yeah.
let me open the picture in new tab. See, this is my whole device. Okay, this is one router. Okay,
Yeah.
or this is the Nexus switch, you can see. So these are the line cards where your users can connect it, or from these ports your servers may be connected. Okay, and
Yeah.
there can be lot of servers, lot of users connected on these Nexus devices, right?
Yes.
These are
Yeah.
your line cards named as IOM, named as data card. Why? Because they are handling data. These cards are handling data. All of these cards from here to here, here to here, they are handling data. Now,
Okay.
for control plane, you have this. There are two devices you can see here. One is
Yeah.
here, one is here, right? So this is
Yes.
control plane.
Okay.
So for control plane, you have, or you can say CPU, okay? Brain. These are the brains, one and two, in the redundancy. If one fails, two will take care. Okay,
Okay.
bit like that. These are named as supervisor engine. Getting my point?
Yeah. Yeah.
So whole kind of routing or every kind of stuff will be taken care by them, control plane. And they will send this information to these line cards. Line cards have small chips, very small memory. Okay.
Yeah.
So that if data is coming from here and it need to go from here, my CPU intervention is not required. From this memory, I can take the decision. Are you getting my point?
Yes. Yes.
For the same thing your SAP is doing. Okay? SAP is
Yeah.
doing same stuff. So in case of your SAP, it maintains some table. Okay? Like it maintain a table named as FIB, forward information based. Like whatever the thing was there into your RIB, into your main CPU, is now sent to whom? To the fib. So here, let us say you have fib. Earlier, there was a lib.
Yes.
There was some kind of ARP table, right? Here, you are just making some kind of table named as adjacency. So I will show you this table also. I will show you the Wireshark capture. I will show you the lot of debugs. Don't worry. I will show you everything. But today is your introductory class, so I am just talking in the theory.
Yeah, yeah.
I hope you people are able to understand.
Yeah, yeah. It's okay.
So that is how SAP is maintaining some tables. And now, if even before coming first packet, even before first packet is coming, these tables are built. And if no destination is there, that will be silently dropped. No need to involve CP. CP involvement is not required.
Okay.
Any doubt?
No, it's okay.
Okay, if it is fine, let us wrap it up over here.